Okay,
Our next speaker is Nate Price.
good. Unmute mine or just,
It's fine the way it is.
okay.
Yeah.
All right, so hello everyone, I'm Nathan Rice, and for my undergrad data science capstone project, I worked with a New England nonprofit company called Green Energy Consumers Alliance, and I built a web application for their renewable energy certificate allocation task and inventory management. So the inventory that we are managing is made up of renewable energy certificates. So when you turn the light on in your house, the power comes from a supplier, goes into the grid, and then finds the path of least resistance to the light. But we don't know how that energy got there, what supplier that energy came from to do that. So that's why there are renewable energy certificates. So this is the only way to prove that the energy you're using actually came from a renewable energy source. So for every megawatt hour that a renewable energy supplier produces, there's one renewable energy certificate that goes with that. And what Green Energy Consumers Alliance does is they buy the RECs, the renewable energy certificates, wholesale from the suppliers and sell them at retail to businesses, towns, and individuals. So why buy RECs? There's state law. There's a renewable portfolio standard that they issued in 2003 that requires electricity suppliers to have a minimum percentage of their sales going to end user coming from renewable energy sources. So from 2020 to 2029, the minimum percentage requirement is gone up 2% every year, and then 1% thereafter. And so this promotes the growth of renewable energies suppliers and the use of renewable energy. And so what you see in this table is the schedule of those requirements and how they increase over time. And also when we talk about class 1 renewable energy certificates, these have to come from new suppliers that are installed after 1997. And so this is this bar graph here is showing the actual sales of those renewable energy, class 1 renewable energy certificates and how they've increased over time. So the idea is that when you buy a class 1 renewable energy certificate to offset your energy use, that's one less REC that the electricity suppliers will have to buy, and therefore that encourages new suppliers to come on and generate those RECs. So this is a screenshot from the Excel sheet of the green energy planning model that they use to organize their data. So this is what I got at the beginning of the project to work with. And it's as they've grown over time, there have been more suppliers that have been added, more products have been added, and it's just been difficult to work with this Excel file. And it's just been growing and changing over time. So what you see here is each block is a supplier. And so you have Hull 1 Wind is one supplier, Hull 2 Wind is another supplier, and then you have their total available supply by period. And what they've done here is the blue numbers in the total available by period row are actually estimates for their estimates of future supply that they will be getting in. And they are actually overwriting those numbers with the actual numbers once they get those in black. So they're not tracking their estimates. So that's one of the things that I've added into this project. So this Excel file has become difficult to work with There's a tab for each product. And just the structure of it is not allowing you to filter for any data or query the data for what you need to answer any questions. So I've reorganized the data into a relational database, and here's the schema for that. So we have a suppliers table with all the information from the renewable energy suppliers, the name, the cost per megawatt hour, if it's restricted to use in a certain area, the energy type, and then I've separated out the actual RECs that are available and the estimated RECs that are available so that they'll be able to track their estimates moving forward and analyze those. Then we have a products table, so that's the demand side with the load obligations that they need to meet and information about the products. And then the allocation table is like sort of like a transaction register, which says in this quarter, this many RECs came from this supplier and it went to this product. So we're tracking that data. And then I have two additional tables that are more detailed information about two products that have subproducts within them. So GMA is actually has towns, and each town has its own demand, so that data is stored there. So this is an example of the suppliers table, where you can see that when it's structured in a tabular format like this, you're able to query the data, filter by energy type or filter by name or cost, and so that way you're able to answer any questions you might have of the data. The motivation for the app was to make a tool that is user-friendly and interactive and allows them to do that REC allocation process where they're taking the supply from the suppliers and allocating those to the product demand that they have to meet each quarter. So this reduces the errors. They're manually entering numbers into that Excel sheet and a lot of circularly dependent formulas in the Excel sheet. So reducing errors there. We're providing I'm providing a persistent data storage, and it's an extendable framework, and we can add things on and do more data analysis than we could with that complicated Excel structure. So now I'm going to show the app here. So this is the app, and so I designed it to one, manage their inventory, and two, be a tool for that allocation task. So the person's going to be looking at the total load obligation of those products that they have to meet, and then they're going to go and look at the supply and allocate those RECs from the supply to the products. And when the app first loads, it is loaded up to the current quarter. So this product demand quarter is filtered by that quarter. And also we have a suppliers table that shows all the information about suppliers for that quarter. So there they can filter by quarter, choose any quarter they want, and the numbers will change according to that quarter. They can also choose a certain product to look at, and they'll get only that demand from that product specifically in that quarter. And these numbers will change to reflect that. So as you're doing the allocation task, you look at that supply, and you'll have those total numbers at the top for reference during the allocation process. And then we'll go to this table for REC allocation, and you can filter on any of these variables if you need to, and type in the allocations there. So if I go to the last page, we have 2022 Q4, and then I would just type in however many RECs I wanted to allocate to this product from that supplier. And then I would save that allocation to the database. So when I save it to the database, you get this message that data backup is successful and the new allocation data has been saved to your database. So it's actually taking a backup of the data before you made those changes, just in case you need to roll back to the original state. You can also add a row for a new quarter or add a new column for a new product. I have the export option here to export to Excel if they need to do that, and toggle columns, hide any of these columns. And so also you're able to edit the suppliers table. If you want to add a new supplier, and same structure there, you can save that to the database. Also edit the products table. So this is a tool for them to use for their database management and managing the inventory and doing that allocation task. So exit this. So this is a web application, but I needed to keep this offline for data privacy issues. So I've bundled this app in to deploy to them using PyInstaller, which is a library in Python. And I'll bundle up the whole program so that way they have an executable file that I can just ship to them and they can click that. And I have a script that will start the app executable and then open the browser to the local host, which is what the app is running on. And includes a user guide for them. So yeah, thank you to Scott Field and Michaela McCarthy from Green Energy Consumers Alliance for making this project possible. It was challenging, but it was fun. And I'd be happy to answer any questions or comments that you guys might have.
I have a question for you. So you are obviously giving credit to
Sorry, go ahead.
Can you hear me?
Yep, go ahead.
You're obviously giving credit to Michaela McCarthy. Are they going to implement your project? Are they going to adopt it?
Yes, I've been having meetings with her throughout the whole project, and I've shipped the app to them, and they've given me feedback on the app, and then I made improvements going forward. So yeah, I'm going to continue being in contact with them to provide support, and they'd like to use this product in their business. Yes.
While this is not really under your purview, but how is Green Energy Consumer Alliance related to NSTAR, what was it, National Grid and Eversource? Do you know?
Yeah, so Eversource is actually a customer of theirs. So like I said in the previous slides, they have to have a certain minimum percentage of their energy coming from renewables. So they buy renewable energy certificates from Green Energy Consumers Alliance to fulfill those state requirements.
Thank you.
So last time I know that they have a person money in Excel, and it makes life difficult. But right now when you do it like this, it's pretty nice. So how did you save the database under the hood? Is it using HDFI or Excel or whatever?
So it's all in Python, and I'm using SQLite.
Okay.
So I created an SQLite database with that relational schema that I showed, the suppliers table, products table, and allocation. And then the dash editable data table, when they entered I'll just keep it up for reference. So when they enter these numbers in these tables, and they click Save to Database, it's actually doing an import statement, and it's taking this data frame, it's a pandas data frame, and it's taking that, there's a function called toSQL, and it's replacing that table in the database. And so that's how it gets saved in. And then when you change that, you refresh the page, and all those numbers are updated on the app because it's downloading from the database when you refresh the page.
Okay, so then why do you choose SQLite over other databases?
SQLite is probably the simplest example of a database. It has, one of the reasons I chose that was because the way it works is just one file. So you have an SQLite file that contains all your data is just one file. So when I do the backup, I can just write up that to a file, and it just saves in the same app folder. And so that way it's like easy for them if they need to, you can make an archive of that, a backup and an archive of that, just by copying that file by itself. And also it works with Python. And so, yeah, that's why I chose it.
Any other quick question before I have time for? Okay. All right, if not, let's take a